I'm going to talk this morning about carbon, a new currency for construction, and introduce a plan of how we can reduce our carbon impact. So 7 months ago, we started a conversation in Curtins, and these were the sort of key issues we were thinking about. Climate change is a reality. We weren't going to question that. We believe we have a moral duty to act, and our own people and the people in society want to change. They want to make a change now. We were a signatory to Engineers Declare. So what did that mean? Were we going to do anything about it? And we agreed that we needed to start now with some small steps, just doing something every day. We recognised it was a huge challenge and a huge opportunity, and that this should introduce a year and indeed a decade of action. And I think that that can be our starting point today for this presentation as well, those 7 points above. So the presentation is going to split into a few sections. Why do we need to do anything? How we measure carbon, this whole concept of carbon as a currency. I'm going to look at my own personal carbon impact and the professional impacts that I have during my year of work, if you like, and then look at the plan for reducing our impact collectively. So first of all, why do we need to do anything? I guess I could have chosen any of 100 photos for this, from polar bears to ice caps to forest fires, etc. This is the one I chose. It seemed most appropriate. This was from the fires in Australia at Christmas, just at the start of this year, and wholesale reduction of habitats, loss of life, destruction, and carbon dioxide released into the air. It's not isolated though. 2 days ago, I took this off the internet, which is a fire in California in their longest and most intense fire season ever. And in case we're feeling left out back in the UK, this was Lancashire, Bolton of all places, in 2019. And again, tinder dry conditions being conducive to fires throughout. So those 3 slides really capture why we're doing this. And I wanted to set this in some sort of context. There's a timeline here, which only after I'd drawn it, I realized was pretty much in line with my career. I started in 1990, and these are the events that I've seen. Firstly, at the top, on a global scale, the IPCC saying in 1990, something's happening in the environment, but we don't know what it is. And the increasing concern, which you can see across that top bar there, of their reports as they've become more and more worried about the situation. Significant effects sort of nationally and in Europe as we've gone along the line here. I/T meeting to discuss sustainability. What happened there? BREEAM, the database of carbon and energy, the IC, which I'll talk about in a minute. And then for me, this has been a really slow curve until 2018 when all of this happened. And I feel that was when the world really started to wake up to it. Blue Planet, David Attenborough, Greta Thunberg, etc. In my own career, I designed a building around here and I looked for examples of sustainable design and found this. I didn't realize at the time it was a Curtins building. Exposed slabs, natural ventilation, night purging of concrete, etc. I worked at BDP. I set up a carbon assessment tool, and around basically measuring embodied carbon. And around that time, some brave souls in Sweden decided to build an all timber car park, and I thought that sounds good. So I tried to get one of those into South Wales. We had a couple of car park projects. Nobody was interested. This is crazy. Why are you doing this? It'll burn down. All of those sorts of things. And after you've done that so many times and everybody keeps saying no, you drop it after a bit. And I feel there's been a general level of client reluctance through the last 10 years. But it's all changing. Clients are realizing that their customers are starting to demand this. So we start again with our assessment tool and this initiative. Really passing reference to the United Nations Sustainable Development Goals, which underpin much of what we're talking about. I'd urge you to have a look at that. There are 17, I think, of them. They range from everything from the education of girls in Africa, bringing about reform in those countries, through to sensible design of buildings. Really worth a look. So we come on to measuring carbon, and on the basis that we have to measure it if we're going to improve it. So this slide is me trying to get my head around what a ton of carbon dioxide looks like. If you fill both those standard garden water butts with petrol and set them on fire, the gas released is about a ton of carbon dioxide, and it would look about that big. measured against a sort of standard sized American house there, about an 8-meter cube. Some definitions to allow us to go into this talk in more detail, just pick out a couple of them. CO2 equivalent is what we're going to be talking about. So even when, for example, nitrogen oxide or methane is released into the air during the processes we're going to talk about, they can all be reduced to a carbon dioxide equivalent. And we use those units and that naming convention of CO2e. Net zero carbon down at the bottom. The UK government target for 2050 is referring to operational carbon only, which is obviously running our buildings, running our cars, etc. The embodied carbon is not addressed in the net zero carbon, and this is the carbon locked up in materials, making a car, making a pencil, whatever. So that, as engineers, is where we'll be focusing today, but there are much broader lessons from both of those which will come out as we go through. So in order to talk about this, we've got to build ourselves a carbon awareness and a carbon instinct so that we can talk with our colleagues and discuss carbon in these terms. And I'm going to start with this, which is a book I bought about 6 months ago. It's fantastic. It's a light reading paperback, 6 or 7 quid. And it is about the carbon footprint of anything from a text message up to, say, a volcano. And carbon analysis is either from the bottom up or from the top down. And just to summarize those two different opposing positions, if you were looking at the carbon analysis of a pencil, you would say, well, what's the carbon in the lead and the clip and the case? And you'd add them all together from the bottom up and you get a number. But if you did it from the top down, you'd look at the carbon emissions of the factory that they're made in and the bloke driving to the factory and all of the materials used and wasted in the production of the pencil, divide it by the number of pencils you've got, and you get another number. And it's much bigger than the first one. And the difference between the two is leakage. So we need to understand that in order to get reliable data for measuring carbon. And happily, someone else has done it all for us. This was started by Craig Jones at the University of Bath, I guess 15 years ago now, maybe more. And in it, he's done data sets of perhaps up to 1,000 different production processes, say, for example, for steel. And out of it has come a number which he believes he and his team believe are representative and can be used as calculating the carbon impact of something. So here, for example, a kilogram of steel will have a carbon impact, of 1.55 kilograms of carbon. So you get the weight of steel, multiply it by a number, and out comes the carbon impact. And that is the same for many of the common materials. So we'll revisit that in terms of our professional outputs in a few minutes.